Okay, ladies and gentlemen, what we got going on here are inverse functions. We're looking at section 1.5 in your pre-calc 12 textbook, okay? We've looked at a bunch of transformations. We've looked how to slide them back and forth. We looked at reflections over the x and y axis. I guess maybe the reflections are, let's have a look quickly at where we're at. So we had a function originally, this representing any function, right? And it goes into a bunch of transformations. A affects the vertical, it's a vertical stretch, right? And then this B value affects the horizontal, so it's a horizontal stretch, right? Either compression or expansion. Then you have a horizontal slide or a translation, and then you have the vertical slide or translation. Now, hopefully you can identify which one of these variables, A, B, C, or D, is involved in those reflections, right? The A value is what involves a vertical flip, right? If A is negative, it flips over the y-axis, so from up here to down here, or from down here to up here. If the B is negative, it flips it over the y-axis this way, okay? The x's are flipped. Now, we have one other type of reflection, and that is an inverse function, okay? Now, the first thing we have to understand with inverse functions is that they are, what does the word inverse mean? It's the opposite, right? Or upside down, or inside out. So these concepts can be used to understand what inverse functions are. They are essentially the opposites of each other. They are the upside down functions. They undo each other. So the first thing I want to write down is that inverse functions, okay, they undo each other. And one way to think about it is that, what can I say? Your x and y's actually get flipped as well, okay? So x and y are flipped or inversed, I guess, if you want, for lack of a better word, right? So x becomes y and y becomes x. Okay, so if you're given a point, for example, if you're given a point, say point on function f of x is 2, -3, right? Then the point on the inverse is -3, 2. Your y becomes x and your x becomes y. So I guess another thing that we want to write down is the symbology, okay? So f -1 of x is used to denote inverse function, okay? Now, some of you might be asking, you remember that if you have x to the power of -2 or -1, okay, you know that's equal to 1 over x. Now, this is not what that refers to, okay? This denotes only an inverse function. You are not flipping it over, okay? Let's have another look. So what else can we talk about here? Since your x becomes y and your y becomes x, think about what happens on a graph. Okay, let's use this point that we were talking about before. If I have 2 and -3 on f of x, if you inverse it, so 2, -3 becomes -3 and 2, so -3 and 2. Now you can see that this is a reflection, but over what line, right? You can think of it as a reflection maybe, no, you can't even do that, boom, boom, no, it's not both directions. It's a sort of a rotational thing, but basically what happens here is that it's a reflection over the y equals x axis, and that would be this line that runs right up here. This is y equals x, all the way down here. And if you put a mirror here, you can see that the reflection would end up over there. So a big part of this is that it's a reflection, okay, over the y equals x axis. Simple as that. And very basic to find the points. Like I said, you just flip the x and y's. Okay, keep the signs on them, and visually it's a flip over this axis. So we'll have a closer look at that again. How do we solve them algebraically? So let's look at something here. So given, okay, f of x is equal to 2x minus 1, I'm going to say find f minus 1 of x. So the first step is flip your x and y. So since this is the same as y equals 2x minus 1, the first step would be x equals 2y minus 1. X becomes y and y becomes x. And the second step would be solve for y. So you're going to have x plus 1 equals 2y, and then you're going to solve it for y. Y is equal to x plus 1 over 2. Okay, and this would be the inverse. So your inverse function of x will be x plus 1 over y. Sorry, over 2. My apologies. Now, if you look at this, this can also be rewritten as 1/2 x plus 1/2. So what I'd like you to look at here now, if this is your original function, okay, if this is your original function, let's graph it, right? 2x minus 1. Minus 1 is my slope, my y-intercept, a slope of 2, so up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Let's go backwards, down 2, back, there we go. So that's f of x. If I was going to graph this right here, okay, if I'm going to graph that one there, let's slide it over. Up a half is my y-intercept, and a slope of 1 over 2, 1 over 2, 1 over 2. And similarly down here, back 1 over 2, or sorry, down 1, back 2, down 1, back 2, down 1, back 2. And this would be my inverse function. Here's my f minus 1 of x. What I'm hoping that you can see is that we do have a reflection right over this xy axis, okay? Or y equals x axis. You can actually take individual points and check it out. Look, 2, 3, and then you have 3, 2, right? It ends up right there. So your inverse is a reflection over the y equals x axis. All your x values become y, and all your y values become x. Now there's a few other things that we have to take into consideration here, folks. We have to take into consideration one-to-one function. If you look at the original function here, that is a one-to-one. Vertical, horizontal line tests are passed, okay? If you look at the inverse, vertical and horizontal lines are passed as well. So the inverse of this function here, or the inverse of this function, is still a function. Now you can think about functions that might not be functions when you do the inverse. One of the most obvious ones, for example, is a parabola, right? Because if you flip it, it goes like this, and it's no longer a function. So if it's not a one-to-one function, the inverse won't be a function. You're going to need to be able to identify those, and the best way is knowing what they look like, knowing what a parabola looks like, knowing what a radical looks like, knowing what a rational looks like, knowing what a absolute value looks like. Very beneficial knowing what these functions look like, okay, in order to identify whether they're one-to-one or not. So we could verify that these are indeed inverses by plugging them into each other, but we can maybe look at that in class. Let's see what else I can find here for you. So we've got the graphs, we've got some algebraic ways. Let's pick another one here. So say g of x is equal to the square root of x minus 1. I'm going to ask you to find the inverse of that function, okay? And what we're going to do here is we're going to replace g of x with y just to make it easier for us to see what happens. And then the next step would be to replace the y with the x and the x with the y. And then the last step is to solve for y, okay? So now you have to solve for y, okay? And basic algebra rules here apply. How do you get rid of the radical? You have to square, right? So x squared is equal to the square root of y minus 1. And then you're going to have x squared plus 1 is equal to y. So then your f negative 1 of x is equal to x squared plus 1. Now we have to back up a little bit here and see if this makes sense. We got some built-in restrictions here. We've got something that's going on here. First of all, can you graph this? Okay, it's a basic radical function that starts here, boom, up it goes, but it's slid right one. So it starts here, and then 1 and 1, and 1, 2, 3, 4, and 2, and we have this is my original function, g of x. Now, if we look at this here now, we can see that we have a parabola that's gone up 1. So boom, I'll put it here. And if you look at the graph, over 1, up 1, over 2, up 4, over 1, up 1, over 2, up 4, we have the whole parabola. So the radical functions and the quadratic functions, they are absolutely related. However, we know that this inverse here is not a function. You can see it, right? But there is a portion of this thing that is indeed the inverse of this function right here. Let's draw that axis of symmetry that we've been talking about. This is that y equals x axis. Now, you can see that this is broken into two pieces, kind of. You got the right side, the positive side. You got the left side, the negative side. Which one of these would actually be the inverse of that, right? Is it this side or is it this side? I'm hoping that you can see that if I get rid of this part right here, these are the inverses of each other. You can actually even take points. Look, 2, 1 becomes 1, 2. 5, 2 becomes 2, 5. Okay, so this is the actual inverse. So what we need to do here is state a restriction. You need to say that x is greater than or equal to 0. And this would be your final answer, okay, for that inverse. I'm going to show you another one here because we have a little bit, well, some of these can be a little bit tricky. So let's look at another one. P of x is equal to, well, notice that this one only has one variable, right? Notice that the previous one also only had one variable. I can't find this here, but anyways, where is it? Here it is. Notice that the previous one also only had one variable, okay? What happens if you end up with a situation where you have, first of all, two variables, but also a rational expression? It can be a little daunting, a little confusing, but the process is exactly the same, okay? So y is equal to, so we're going to find p negative 1 of x, or the inverse of the p function, okay? First step, make your p of x equal to y, then make your y equal to x and your x equal to y, and you can see why there might be some potential problems here, since the y value, there's two y's. I want to solve for y. How the hell are you going to do this? Well, the only thing we can do with rationals is rationalize the bottom. So let's multiply both sides by 2y minus 3. You end up with a situation like this. Multiply it out, you get 2xy minus 3x equals y. How can we isolate the y so that I can end up with y equals? The idea here is that you have to bring all the y's to one side and everything else to the other side. Hopefully now you can see that there is a way to remove a y from this. And it's called factoring, right? You take out a y, you're left with 2x minus 1, and that's equal to 3x. Finally, you want to isolate the y. You simply divide by this binomial. You end up with 3x over 2x minus 1. And this would be your inverse of x. Okay? One thing you have to remember is that we have a restriction with this inverse function as well. There is a restriction here you could identify. There's also a restriction here that you need to identify to get the whole answer. And in this case, x can't be 1/2. And that is indeed part of the solution. Okay? I got one more situation to show you, and it will involve, again, the radical function. So if I'm given h of x here, okay, and it's equal to x squared plus 2, find, again, the inverse of that function. Okay, so same thing, x squared plus 2 will make the h of xy. Now, this is where it's good to know what the original functions look like. Is this original function a one-to-one function? Well, it's a parabola, right? It's a parabola. It has gone up 2. So here you go, and there's your parabola. Over 1, up 1, over 2, up 4, back 2, up 4. Here's your parabola. You can see that this is a function, but hopefully you can identify that it's not a one-to-one function. Okay, so if it's not a one-to-one function, would you expect your inverse to be a function? Well, let's think about it. So x squared plus 2, here we have it. Let's replace the y with x, the x with y, and then we solve for y. So x minus 2 is equal to y squared. Some of us would rather have it on this side. Okay, I don't care which side it's on. Let's leave it on that side. It's a little bit easier to understand. How do you get rid of the squared? Use square root, use square root. Hopefully you remember from your grade 11 and from dealing with radicals that when you square root a number or an expression in solving, you need to incorporate both the positive and the negative version, right? So technically here, y is equal to plus and minus the square root of x minus 2. So that would be h negative 1. The inverse of h is equal to plus or minus the square root of x minus 2. Now let's look at the connection between these statements here, these expressions, and the graphs of them. This is like a radical that's gone to the right too. The positive version on 1, 4 is up top here. The negative version is down on the bottom. Boom, there you go. Now you can see that this is also a reflection over that y equals x axis. Okay, now we saw that the original function wasn't a one-to-one, so we didn't expect this to actually be a function, right? And that's essentially it. You got to think about these things depending on what questions are being asked. Hopefully this makes a little bit of sense to you. We'll go over it tomorrow in class.